how the system development. So this chapter explains the methodology used in developing the secure Notepad app with encrypted storage and biometric access. The system development methodology provides a structured approach that guides planning, designing, implementing, and evaluating such a system. An adequate methodology ensures systematic advancement, minimizes development risk, and aligns the system features with users' requirements established in preceding chapters. So the methodology that has been chosen is rapid application development. So for developing the secure Notepad application with encrypted storage and biometric access, the rapid application development methodology will be used. RAD is a new paradigm for developing systems that emphasizes rapid prototyping, early and often user feedback, and reduces amount of planning upfront. So RAD is ideally suited for projects in which user interface applications are involved, and usability, design flexibility, and timely delivery are paramount. This method allows developers to learn about user needs instead and refine the system during development. So, for example, we are actually gonna see the user's reaction, the user's take on the system before developing it. That's what it has been explained here. So this project has sophisticated features such as AES-256 encryption, biometric authentication, offline data storage, peer-to-peer encrypted sharing via QR code. These features requires a lot of user interaction. So basically, this methodology is basically doing the project rapidly with also a lot of user interaction, a lot of users take on the system. So the processes in each phase are requirement planning phase. So gathering user needs, evaluating current system, and identifying critical security flaws. So gathering the information that we need in this phase. Next, we have a user design phase. Low fidelity and high fidelity prototype will be made to deceive the application main features and user interface during the user design phase. The way users will interact with key features like encrypted notification, biometric authentication, backup, and restore capabilities. Next, we have the construction phase. The model of the application will be developed in accordance with the design specification during the construction phase. Important features will be put into place such as secure peer-to-peer sharing, local encrypted storage, biometric login integration, AES-256 encryption, and emergency data wipe. Next, we have the cutover phase, where the finished application will be tested. So this is the testing phase. The cutover phase basically means the testing phase to make sure all security and core features are operating as planned. So these are the diagrams for each phases. So this is for the requirement planning phase, and this is for user design phase. This is for the construction phase, which is the most important part, where the system is being developed. Next is the cutover phase, where basically it's a testing phase, where we test the system or the app with users. Next, the technology and test tools that are used. First of all, Android Studio. Android Studio is the most important tool here because this is an Android-based app, not an iOS, not a desktop-based app. So the official integrated development environment IDE for creating Android application is called Android Studio. So it offers integrated debugging tools, devices emulators, and a robust code editor and a real-time preview tools throughout. So this is the Android Studio. Next, we have Java. Java is the main backend of the whatever we're gonna use to code is we are gonna use Java language to code this system. So this language we use to implement encryption algorithm, biometric login, file storage, and user interface interaction. So Java was chosen as the main programming language for the application logic because it was compatible with Android development and supported cryptographic libraries. Next is Android Biometric API. So this API is used for the biometric part, where the fingerprint part. So this API will be used. Next is SQLite. SQLite, a structured data can be stored on the user's device using SQLite, a small embedded database. It was selected to manage node records locally and securely without requiring a cloud server or internet connection. So that is why we are using SQLite. Next, AES-256 encryption as the main encryption body, where it will be all the nodes will be first encrypted by AES-256 encryption. Next is XML and Android UI components. Android developers use XML to create user interface layout. So the main interface layouts are created using XML. It specifies how UI components like button, text field, dialog boxes, and biometric prompts should look and feel. Draw.io is all the diagrams that in our system development will be used to be drawn using Draw.io. Figma is used to use prototypes and wireframes, and all our interfaces will be used to be created by Figma. So this is the technology and tool architecture diagram. As you can see, the development tools and the mobile application tools are here and how they work in a diagram. And the hardware requirement for this is a laptop or PC, which is minimal Intel Core i5 processor and 8 GB RAM, 256 GB SSD with support for Android Studio. Next is the Android smartphone to be tested, the app, and the external storage device to test the backup part. Next, the software requirement will be an OS, a basic OS, Windows 10, Mac OS, Ubuntu, Android Studio, Java Development Kit, JDK, Android SDK and emulator, VSC as the main place where we're going to code our system, SQLite, Figma, and Raw.io. So now we're going to look into the requirement analysis and design. So the requirement and design, system design for a secure Notepad application with encrypted storage and biometric access are the main topics of this chapter. Its objective include defining the system functional and non-functional requirement, modeling the system structure behavior with OOP design tools, and outlining the database and interface design. So requirement analysis. Both functional and non-functional requirements for proposed system are specified for the requirement analysis. Before starting the requirement analysis, a survey was taken within people from different workforce to analyze the need and technology required for this mobile app. So this is a use case diagram as we can see for this application. There will be a detailed information here. So this is the function requirement of offline biometric encrypted Notepad app with customized security. So these are all the use cases that will be used. So there are 11 use cases. Just login with biometrics allows allow user to log in with passphrase, create node where the user can create the node, delete node, the user can delete the node, restore the node from a backup. The user will have an option to restore the node, edit the node, perform offline backup where before we restoring, we need to perform an offline backup to be able to restore after an auto wipe. And also share node via QR code where the node can be shared via QR code, trigger an emergency wipe, as just now I mentioned, where when it reaches the threshold, there will be an emergency wipe, and encrypt and decrypt the node. So these are the use cases that will be needed to develop the system. These are the actor description where there are there are one actor and other two APIs and also a local storage system. So the user and Android biometric API and ZSync QR API. So which external library that handles QR code generation, scanning, enabling, and secure peer-to-peer node sharing. So a passive actor that stores encrypted nodes, backup files, and handles offline restoring of the nodes is the local storage system. Next, for the first use case, which is the login with biometric, the actors are user and Android biometric API. So this use case describes how the user authenticates and logs into the app using fingerprint. So the precondition should be the user has created an encrypted nodes with an optional fingerprint, and the fingerprint function should be enabled because it's an optional and a customizable Notepad app. The encryption is customizable, and the post condition should be the user granted access to the nodes. And the flow is the user opens the application, the system prompts for biometric authentication, the user can scan the fingerprint, and the user enters the node. And there is no alternative flow, and the exceptional flow is when the biometric fails and they use a passphrase, and the system displays biometric authentication failed. So this is the first use case, login with biometrics. Next, login with passphrase. Same as login with biometric, but here we will use a password. So these are the details for login with passphrase. Next is a use case to create node, and the actors involved the user and Android biometric API. As to create node, also we need a biometric authentication to create the node. And the flow will be the user enters the app and the system prompts for biometric authentication. The user scans the fingerprint, system verifies it. The user is logged in and redirect to the node page, so where he can create a new node. So this is a use case for delete node. So when you delete a node, also you need a user and also an Android biometric API where you need to be verified. You need to be verified as a user to delete a node. So restore a node. The user can restore the node from a backup and a local storage. This is a use case description for edit node. This use case allows the user to modify content of existing node. The user logged in and nodes exist. This is the precondition. The post condition, the nodes will be edited. So, and after editing the node, the user must save the node. So the node will be saved to be used next time. This is the use case to perform offline backup. So the user needs a user and also Android biometric API. This use case allows the user to backup all encrypted nodes to local or external storage without using internet or cloud services. The user logged in and nodes exist. A secure backup file containing encrypted node is saved to local or external storage. The user navigates to backup section. The user selects offline backup. The system collects all the encrypted node data. The user selects a target storage location. So this is the flow of the use case description for perform offline backup. The use case description. This is a use case description for the share node via QR code. So this needs the user Android biometric API and also ZSync QR library. This use case allows the user to securely share an encrypted node with another device by generating a QR code enabling offline transmission. So details are as below. Next is a use case for trigger emergency wipe. So this use case allows the user to delete all the encrypted nodes after a set number of failed login. So basically, this is not the user. This is another person who trying to brute force attack, or who trying to enter the nodes without correct passphrase. When the threshold is met, the nodes will be deleted automatically. Next is the use case for encrypt the node. So this use case allows encryption of a node using AES 256 to ensure confidentiality. And the same, this is to decrypt the node.